Today's question is minimum ASCII delete sum for two strings. So we have been given two strings S1 and S2 and we have to make them equal. And to make them equal, we have to remove some of the characters from the both of the strings. So whatever character we remove, we have to sum up their ASCII values and return the minimum ASCII value so that the both S1 and S2 are equal. So in this we can use recursion plus memoization approach. So first let's try to create a helper function as we do in all question. So it's a DP problem normally. So we can take the index of the 2 and then the string itself. Now let's write the best case afterwards. First, what if both the characters of the string matches? So we can simply if s1 of I is equal to s2 of j, we can simply return helper function and we will go to one index further. And second, if not match, if they don't match, so either we will remove from the first string or we will remove from the second string. So what if we remove from the first string? So it will be body of s1 of I. We remove this, okay, and it will be self dot helper function. We remove I means we go to I. Next step, then j, then s1 comma s2. And what if we remove from the second string? So body of s2 of j, s2 of j plus self dot helper function of we are incrementing j. So means we are removing j, so we will go j plus 1 s1 comma s2. So we need the minimum value, so we will simply return the minimum of these two things. First removing the from string 1 and second case removing from string 2. Now what will be the best case? Best case will be suppose we reach at the end of each of the string if suppose I is equal to len of s1. So we have to remove all the elements from the s2 so that both the string gets equal. So simply return take the sum of ORD of all the t is the character in string s2 for t in s2 from j to all. Similarly, if j is equal to len of s2, so we have to remove all the characters from the s1. So simply return sum of ORD of t for t in s1 of I to last. And now in the main function, we can simply call this helper function and pass the index 0, 0 and the string itself. 0, 0, we have missed the comma here. Let's try to run this. Let's see if this works. DP approach. So this work. But when we will try to submit it, this will give DLE. So we will have to apply DP here. So simply DP is equal to first we have to take out the length. N is equal to len of S1. Then M is equal to len of S2. Simply then go 0 for I in range M and for I in range N. Now simply pass TP here. Now we will store this minimum value in the DP. So DP of I j is equal to, let's cut this part and paste it here and simply return DP of ij. Control C, Control V. And now, before going inside any new recursive call, we will first check if dp of ij is not equal to 0, then simply return dp of ij, and let's pass the dp to our all functions here. Dp, here also dp, and one more here. Now let's try to run our test cases. Yeah, test case have been passed. Let's try to submit this now. Okay, so our code has been passed. So, but you can see it's too slow. So we can use the tabulation approach also here. So for tabulation approach, we can simply increment this value m2 m plus 1 as we, this is bottom of approach. So we can simply you can create the base case. What is the best case here? If one of them exhaust. So suppose S1 exhausted. S1 exhausted. So we will go for I in range. For I in range S1 exhausted means M1 means S2 is remaining. So minus 1. Then simply we can calculate dp of S1 exhausted means N is already there. Just this I. This I needs to increment. So simply we will add ORD of S2 of I plus dp of n will be same. We will increment the I plus 1. Similarly, S2 exhausted. S2 exhausted. So simply we will go for I in range n minus 1 to minus 1 minus 1. We are going from right to left. So dp of I and S2 is exhausted. So simply sum ORD of S1 of I, ORD of S1 of I plus dp of I plus 1 m. Now we have created the base case. Now if we are in recursive we are going 0 to last, here we will go from last to 0. So simply for I in range n minus 1 1 comma minus 1, p for j in range n minus 1 comma minus 1 comma minus 1. And now we will simply copy this recursive path. Same recursive logic. Let's copy it from here, paste it here. So if S1 is equal to S2, we will see we are going to I1 plus J1 now, but here we are using DP table. So DP of IJ is equal to DP of I plus 1 J plus 1. Else this is not the case, then simply this logic will work here, and dp of ij is equal to minimum s1 of ij plus this thing will be replaced by dp of I plus 1 j, and similarly this will be replaced by dp of I plus 1 j. Let me check, is that correct? No, we have put the same thing here. Here j is incrementing, so put I, increment the j value, and simply we can return here dp 0 0. Let's check if this works or not. dp of 0 0. Yeah, let's submit it. You can simply remove your recursive code from here up. You can remove your this recursive code. Well, let's try to run it again, and let's try to submit now. Yeah, so our code has passed and this time we have bet 89%. So thank you.